Okay, so now instead of stretching things vertically, we're going to stretch things horizontally. So it says let b be a positive real number, and the period of this equation, y equals a sine b theta and y equals a cosine b theta, is given by this formula. You have to know this formula. Period is, again, how long it takes us to repeat ourselves. And if you think about going around the unit circle, we start here at 0 and we go all the way around. None of the x or y values repeat themselves until you get back here to tell 2 pi. So the period of sine and cosine, the parent function, is 2 pi. When we throw this b in here, however, we can stretch and shrink how long it takes us to go around the circle. This b thing, remember, is, and my kids will know this thing, it's a girly thing. It's on the inside with the x stuff, and girls are always backwards. So if the absolute value of b is when is it a stretch? When the absolute value of b is less than 1. And it's a shrink when the absolute value of b is greater than 1. And if b is negative, we're going to reflect over the y-axis. So it says that I want to sketch a graph of y equals sine theta over 2. So I'm going to rewrite this: y equals sine 1/2 theta. And before I do anything else, I'm always going to start my graphs by doing this little table. The angles never change for sine and cosine. It's always 0, pi over 2, pi, 3 pi over 2, 2 pi, and then you have to check what trig function you have. You have sine, so you're looking at the y part of the ordered pair. So at 0, sine is 0, and then 1, 0, negative 1, 0. And according to this equation, I'm going to take all of my angles, so angle stuff. Okay, this says multiply the angles by a half. It's a girly thing. It's backwards. So instead of multiplying by a half, you're really going to divide by a half. And when you divide by a half, it's the same thing as multiplying by 2. So either write divide by half, or I would prefer to multiply by 2 because I know how much you all love fractions. So I'm going to take all these angles right here, and I'm going to multiply by 2. So 0 times 2 is 0. Pi over 2 times 2 is pi. Pi times 2 is 2 pi. 3 pi over 2 times 2 is 3 pi. And then 4 pi. And I just want to prove something before we graph it so that you know you're doing this right. 2 pi over b should be my period. So 2 pi divided by, right here, 2 pi divided by my b, which is 1/2, is the same thing as saying 2 pi times 2 over 1, which means 4 pi. So it should take me a distance of 4 pi until I repeat myself. So let's make sure that when we draw here, the distance I cover is 4 pi so that I can repeat myself. So I'm just going to graph. Here are my angles. So at 0, for the y, I'm at 0. And at pi, I'm at 1. Pi, I'm at 1. And at 2 pi, you're back at 0 again. And then you're like, oh, but I'm off the map here. Well, yes, but no. If this side goes up, then you know the other side has to go down. So you could go this way and go over to 3 pi and say, okay, well, I'm down here. Or you could go backwards a pi and go down 1, and then right here be at 0. And now, if I draw my little graph, how long does it take till I repeat myself? Well, if I start here at negative 2 pi and I'm at 0, and then over here I'm back at 0 again, and I've done my whole up-down pattern. Negative 2 pi to 0 is 2 pi units. 0 to 2 pi is 2 pi more units. So this whole distance is 4 pi. It took me 4 pi till I repeated myself, which is exactly what we calculated the period right here to be. Okay, so now the next one says that we're going to sketch this equation. And there's two things going on, and so what I'm going to do is I'm going to really show you how to make this table useful for yourselves. So theta, and then I'm going to leave some space, and I'm going to put my y, and I'm going to graph. So again, these don't change. 0, pi over 2, pi, 3 pi over 2, 2 pi. And then sine at 0 is 0, 1, 0, negative 1, 0. So here we go. I'm going to start with my angle stuff. There's no multiplying in here, but it says minus pi over 3, which really means you're going to add pi over 3. And right here, you're going to multiply all the y's by 0.5. So here we go. Pi over 3, a half plus another third, 3. So this is going to be 5 pi over 6. And bear with me because I'm not using a calculator. So you could type these fractions in your calculator to make this much faster. This is going to be 9 pi over 6. And this is 2 pi over 6, so 11 pi over 6. And then this is going to be 6 pi over, 12 pi over 6, 14 pi over 6, which reduces to, I got to write this out. Shouldn't do math in my head. So this is equivalent to 12 pi over 6. This is equivalent to 2 pi over 6. 14 pi over 6 reduces to 7 pi over 3. There we go. I'm going to multiply and get 0, 0.5, 0, negative 0.5, and 0. You're going to graph your two new columns. So if I go over to my graph, your first ordered pair is right here, pi over 3, 0. And I know you're saying, but there's not a pi over 3 here. But if you think back to your unit circle, here's 0, here's pi over 2, pi over 6, pi over 4, pi over 3. So pi over 3 is closer to pi over 2, and it's more than halfway in between. So like we're just going to approximate. You can put 3 little hash marks if you want, but I'm just going to approximate. Right here I'm at 0. 5 pi over 6, which you know is just before pi over here. 5 pi over 6, you're up at 0.5. 4 pi over 3, which you know is right before 3 pi over 2, you're back at 0. And 11 pi over 6, which you know is just short of 2 pi, is right there. So now you have that much. And then 7 pi over 3, which is right here. 3 goes into 7 2 whole times. So you have 2 whole pi and a pi over 3 more. So you're past 2 pi and at pi over 3, so like right there. So here is your sine wave, like that. Which isn't so bad, and you can progress it back the other way, but now you've done multiple transformations right here using this little table and graphing your new points. So go back to Edmodo and there'll be another video for the next page.